Okay, finite math students, let's talk about your chapter 3 test. Let's go over some problems, okay? A lot of you did very poorly on this test, so let's talk about some of these problems. Remember, I'm giving you another attempt to do this. Don't disappoint me. Get it right this time, okay? Okay, so let's see. Question number 1. And remember, your questions are going to be a little bit different from my questions. Your questions are going to be a little bit different from my questions, okay? Using the interest formula, A is equal to P times 1 plus RT. Solve for the indicated variable. Solve for T. Well, you know what? I'm going to be lazy and I'm just going to use Mathematica's solve command. Solve. Okay, A is equal to P times 1 plus R times T. And what is T? So T is equal to A minus P divided by P times R. Is that correct? Your input is correct. Score 100%. Let's move on to the next problem. Notice, by the way, capital A, capital P, lowercase r. Pearson is case sensitive. So is Mathematica. You should remember that. Okay. I believe this is a simple interest problem. How much interest will you have to pay for a credit card balance of $688 that is 1 month overdue if a 16% annual rate is charged? Okay, so the interest here is actually going to be 16% divided by 1,200. Why is it divided by 1,200? Well, it's divided by 100 because we have to change the percent into a decimal. And then we have to divide it by 12 because we want to know the monthly interest rates. So why not just divide it by 1,200? It's the same thing. 16 divided by 1,200. Now that's giving me a fraction. That's not what I want. Let's change it into a decimal, a floating point number. All right, that's a little bit better. Okay, so let's see. $688 times interest, $9.17. $9.17. Your input is correct. Score 100%. Okay. Let's move on to the next question. Okay, now this question, I actually did this in one of my other videos. I don't know, do I really want to do this question again? Okay. Well, okay, we can go over this again, but I did spend a lot of time on this problem in another video for this chapter. Use the commission schedule from Company A shown in the table to find the annual rate of interest earned on the investment. Note, commissions are rounded to the nearest cent. You know, guys, I'm going to skip this problem because I remember I spent a lot of time on this problem in a recent video that I made, so we're just going to skip it. All right. Yeah. But I have to write down an answer. I have to write down some kind of answer because otherwise Pearson will not let me move on to the next question. So I'm going to write down something that I know is probably the wrong answer, but that's okay. And we're just going to move on to the next question. This is the same kind of problem. Let's move on to the next question. So I did something very similar, guys, in a previous video for this chapter. So let's just move on. Okay. An individual retirement account, or IRA, has $16,000 in it. And the owner decides not to add any more money to the account other than interest earned at 8% compounded daily. How much will be in the account 38 years from now when the owner reaches retirement age? Okay, so clear interest. My new interest is going to be 8 divided by 100 divided by 365. Or I could just say 36500. Let's make it a decimal. Actually, I should really, you know what? Okay, I need to use the 1. There we go. Much better. And $16,000 times interest to the power of, let me see, 38 years times 365 days in a year. That seems like quite a lot. Let's see. $334,372.49. $334,372.49. Your input is correct. Score 100%. Okay. Let's move on to the next problem. How long will it take money to double if it is invested at 6% compounded quarterly? What about 8.8% compounded continuously? Okay, so let's start out with a certain amount of money. It could be whatever you want. It could be $100. It could be $100, okay? So solve $100, $100 times 1 plus 0.06. Quarterly means divide by 4. Okay. To the power of 4 multiplied by the time is equal to 200. What is t? Don't worry about the warning over here. It's not an issue. And actually, if you want to avoid the warning here, it might be a good idea to use nsolve instead of solve. Let's see. Oh, we still get the same warning, but that's okay. So here, it will take about 11.64 years at 6% compounded quarterly. Now, notice the important thing that you should notice right over here, I'm using $100, $200. I don't care. You could use this number, you could use $500, and this could be $1,000. It really doesn't make a difference. All that matters is that this number right here is twice as big as this number right over here. This number right over here should be twice as big as this number right over here. So whatever number you pick for this value, just make sure that you multiply it by 2 for that value right there, okay? Pretty simple. Okay, so for continuous compounding, guys, this number here needs to be very, very big. So actually, all I'm going to do is simply copy and paste. Copy and paste. Let's make this number really big. How about 4 million? And this number has to be the same, 4 million. And that's going to be, let's see, 11.55 years. It doesn't seem to like, wait a minute. Your input is incorrect, score 50%. Hold on one second. So, did I make a mistake here? Hold on one second. What if I made it 4 billion? Yeah, I'm getting the same answer as before. Let me see something. 100 times e to the power 0.06 times t is equal to 200. What is t? No, I'm still getting 11.55. That is interesting. So it doesn't like one of my answers. I want to see something. Let me just type in any silly answer. Yeah, so it doesn't like this particular answer. Oh, because I'm using 6%. Oh, no wonder I'm using the wrong percentage. This is 8.8%. No wonder. Sorry about that. I'm using the wrong percentage. So that should be 0.088. Okay, I was using the same percentage as before, and that's not correct. So this should be 7.88 years. Yeah, that was my mistake. I was using 6%, and it says here that, for this problem, it's 8.8%. Okay, it should be correct. Your input is correct, score 100%. Okay, terrific. Let's move on. Solve the problem using graphical approximation techniques on a graphing calculator. How long does it take for a $2,800 investment at 12%, compounded quarterly, to be worth more than a $3,400 investment at 7% compounded quarterly? Identify the formula required to solve this problem. Let's see. You're not going to use, okay, so this is for continuous compounding. We're not going to use that. This formula is for simple interest. We're not going to use that. Okay. This is also a simple interest formula. We're not going to use that. So the formula for this problem is going to be D. Okay. Okay, so that's the formula that we're supposed to use, but of course, you know how I am, guys. I prefer to use Mathematica, all right? So let's use Mathematica. Let's see, round up to the nearest integer. Okay, so we are going to have two functions. I'll call one, okay, f1, and let's say quarter. Okay, 12%. Okay, so we have interest 1 is equal to 1 plus 12 divided by 400. Why is it 400? Well, 12% divide by 100, make it 0.12, and then you have to divide by 4 because the interest is compounded quarterly. 1.03. All right. So that's going to be $2,800 times interest 1 to the power of quarter. Interest 2 is equal to 1 plus 7 divided by 400, or 0.07 divided by 4. It's the same thing. And remember, why am I dividing by 100? Because I have to change the percentage into a decimal. And then I'm dividing by 4 because the interest is quarterly. So remember, guys, 7 divided by 100 divided by 4, it means the same thing as 7 divided by 400. Just basic algebra, okay? Basic algebra. Okay, so make that a decimal. Okay. Then F2 quarter, $3,400 times interest 2 to the power of quarter. Okay, so the next step, the question is, how many quarters does it take, for the first investment to be worth more than the second investment? And you have to round up to the nearest integer. Okay, so for this, we could use a table. Let's use a table. Table, quarter, F1 quarter, F2 quarter. Quarter is my variable. I don't know, let's go from 0 to 10. I'm just guessing. Let's go from 0 to 10 quarters. Okay, and table format. Let's see, hold on one second. Let me make this bigger. Okay, it's a little hard to read, so let me round to 2 decimal places. Let me round to 2 decimal places. That way things are a little bit easier to read, right? Wait a second, infinity 2. Okay, what did I just do here? Okay, I just screwed something up. Yes. Everything has to be enclosed in a list. Okay. Okay, so, and actually, I could even make this look, okay, hold on one second. So we could, okay, so quarter first investment, second investment. By the way, the /n simply gives me a new line. All right, and I need to close that. Okay, so I'm taking a look. Let's see. First investment, this is still okay. Too small, too small, too small. Okay, so we need to go beyond 10. Okay, that's my doorbell. 1 second. Okay, so if we go to 10 quarters, it's not really enough. Let's try 40 quarters. Okay, so you can see here, let me, yeah, we don't even have to go as far as 40 quarters. We could even go, let me see. Let's try going up to 20. Let's try going up to 20. So let's try going up to 20 quarters. You can see here, after 20 quarters, the first investment is more than the second investment. What about after 19 quarters? What about 18 quarters? What about 17 quarters? What about 16 quarters? So you can see here at 16 quarters, all right, at 16 quarters, excuse me. Hey, Chach, I'm talking to my dog. At 16 quarters, the first investment is greater than the second investment. Here at 15 quarters, the first investment is still less. The first investment is less than the second investment, but at 16 quarters, the first investment is greater than the second investment, which means that is going to have to be the answer. This is the answer because this is the first time that the first investment has a greater value than the second investment. All right? Why? Because $4,493.18 is greater than $4,487.76. Whereas here we see that it's the opposite. $4,362.31 is less than $4,410.57. So the answer that they want is going to have to be 16 quarters. 16 quarters. Okay, 16 quarters. And let's see if Pearson accepts that answer. Your input is correct, score 100%. Okay, that looks great. Let's move on to the next question. What is the annual nominal rate compounded daily for a bond that has an annual yield of 3.8%? Okay, guys, I did something very similar to this in the tutorial video that I made for the Chapter 3 quiz. All right, I did something very, very similar for that video. So if you want to find out how to do this problem, refer back to that video. I don't want to repeat it here, okay? I don't think it's necessary to repeat it here. So we're just gonna skip number 8. Oh, I have to, all right, I have to type in some answer. I'm just gonna type in something silly. And okay, so number 9 is very similar. We did something like this. We did something like this for the Chapter 3 quiz video. I don't think it's necessary to do it again for this video. So if you're not sure how to do this problem, refer back to the other video. Okay? Okay, so I'm going to have to type in some stupid answer because otherwise Pearson will not let me move on to the next question. Let's see. Number 10. A company estimates that it will need 100. Hold on one second. What is my dog doing? All right, guys, hold on. I'm going to pause my video for just a moment. Pause. Okay. So my dog was up to a little mischief, but he's okay. All right, let's get back to this. The company estimates that it will need $172,000 in 15 years to replace a computer if it establishes a sinking fund by making fixed monthly payments into an account paying 6% compounded monthly. How much should each payment be? All right, so I don't mind doing a couple of these with you guys. I don't want to do a whole bunch of them because, again, I did several of these questions in my previous video. All right, so let's clear. Oops, what am I doing? No. This got screwed up. Let me do that again. Shift enter. Okay, so clear global. Okay, clear all of my variables. So now interest doesn't have any specific value. Interest 1, interest 2. Okay, so F1 of 3, F2 of 5. Okay, so all of these variables, all of these definitions have been undefined, and I can start over again. I can start over again from scratch. All right. So here I'm going to say sinking fund month is equal to, let's see, my interest is 1 plus 6 divided by 1200. Okay, 6% divided, well, it's really 0.06 divided by 12, right? So 0.06 divided by 12, 0.06 divided by 12 is the same thing as 0.005. All right, it's the same thing. 1 plus. All right, so yeah. So then you're going to have interest times sinking fund month minus 1 plus, and I'm saving money. I'm trying to save money for a new computer, plus my deposits. And I initially start out with nothing. Okay, so then let me see. How many months are in 15 years? How many months are in 15 years? Okay, so 15 years is the same as 15 times 12, 180 months. So then sinking fund 15 years. Okay, so that's, this is like a really big equation. So why don't we just expand the whole thing? Okay, so this is going to be equal to how much? $172,000. All right, so solve sinking fund 15 years is equal to $172,000. What is my deposit? It should be $591.43 a month. $591.43 a month. Your input is correct, score 100%. Okay, looks good. Okay, let's see. Okay, we did something similar to this problem in a previous video. Actually, I did something like this for your Chapter 3 quiz video. Okay. I'm going to do this problem again. We did something almost exactly like it for the Chapter 3 quiz video. I will do this problem again because I realize a lot of people think it's very difficult. But guys, you've got to buckle down and learn how to do these problems because the majority of the people in this class are majoring in business. If you're a business major, you must understand how to do these problems. Okay, you really must. So let's see what we have over here. Excuse me. So if $1,000 is deposited at the end of each year for 5 years into an ordinary annuity earning 9.18% compounded annually, construct a balance sheet showing the interest earned during each year and the balance at the end of each year. Okay, so let's clear what we have. Start over again, you know, brand new variables, brand new everything. Just erase all the stuff that we have so far. Shift Enter. Okay, terrific. Let's see. Our new interest is going to be, it's compounded annually, so we divide by 1, so that's easy. 1 plus 9.18 divided by 100, because you have to divide by 100, right, to change the percentage into a decimal. Okay. Okay. So then the balance is going to be interest times last year's balance plus $1,000. Or we could put the $1,000 at the beginning. I mean, it really doesn't make a difference. There we go. Okay. And we're going to start with nothing. Oops, we're just going to start with nothing. There we go. Okay, so balance 1. Well, balance 0. Okay, so this goes from period 1 to 5. Chachki, be quiet. Oh, God, my dog has a really big mouth. Okay, so table. Well, you know what? I'm going to do it like this. Hold on 1 second. Hold on 1 second. Okay, so we're going to have table. Balance year. Year goes from 1 to 5. In here, let's do number form. Infinity 2. Okay, so we have, so $1,000. And then we have $2,091.80, $3,283.83. Let's see, $3,283.83, $4,585.28. Chachki, stop. That's my dog's name, Chachki. $4,585.28. $6,006.21. Now we have to figure out the interest, okay, the interest for each year. So this is going to be a little bit tricky. Initially, your interest is going to be 0. I'm trying to think of the best formula to figure that out. For that part, let me see here. If we did balance 2 minus balance 1, you know what it is? It's very simple. So the amount of interest is for any specific number, year, is actually going to be balance year plus 1 minus balance of year minus $1,000 times the year. Amount of interest for the first year now. My only question is, hold on one second. You know what? The problem with my formula is I think everything is shifted over by 1. Because I think this is actually supposed to be, this is actually going to be the interest for the second year. So, hold on one second. Amount of interest 0. Oh, okay. So actually, let me change my formula. This should actually be year. This should be year minus 1, minus 1,000 times year. Okay, so everything is fine except for the negative sign. And amount of interest 3. Yeah, so I think, okay, so so we actually, okay, I have this screwed up a little bit. So hold on one second. Minus balance year. Okay, I'm pretty sure. Let me see. Hold on one second. So let me test this. Okay, now it's really screwed up. Hold on one second. Let me go back. We'll have the right formula in just a moment. Sorry about this. Okay, so we're going to do 1,000 times the year minus balance year. Okay, and then let me erase this. 1,000 times the year minus balance year minus balance year minus 1. And I believe this will be correct. So this should be $0. This should be like $908.19 or 20 cents. Yeah, this is not, okay, so this is really, okay. Hold on a second. This got very badly screwed up. So actually, hold on a second. Sorry, guys. Minus 1,000 times the year. And you know what I'm going to do? We'll just do the absolute value of that amount. I'm pretty sure this is the correct formula. So for the first year, it should be 0. For the second year, $908 and let's say 20 cents. For the third year, $1,807.97. Let's see if this is correct. So $0, $908.20, $1,807.97. This would be $2,698.54. And this would be, okay, so actually, guys, these numbers are really way too big. And I'm going to explain, okay, something's really wrong here, and I'll explain why in a moment. $3,579.07. $3,579.07. So you can see here, if you're adding $1,000 a month, right? If you're adding $1,000 every single month, it doesn't make sense for the interest values to be this large. So something is really off, right? So something is really, really off. So, yeah, 1 second. So for the first period, we have $1,000. For the second period, like $2,091.80. For the third, well, you can see here, actually, something really got screwed up here because this value is going to have to be $91.80. All right. This value over here, yeah, so this formula is not, okay, this is not the right formula to use. Okay, so this is not the right formula to use. Let's do this the long way. So here, to figure out the interest for the third year, all right, you would have to take, hold on 1 second. So $2,091.80. We're going to add $1,000. That gives us $3,091.80. So then $3,283.83 minus $3,091.80. That's going to have to give us $192.03. So these answers are correct. These answers are definitely correct. Now let's see if we can think of a formula that actually does this. Let's try to figure out a formula that will actually do this for us. So this value right over here, all right, that's actually balance. This is hard to write with. Balance of 3. Okay, does that make sense? What did I do? I subtracted 1,000 plus balance. This is hard to write with. Balance 2. Let me close my parentheses. So balance of 3 is actually what I have right over here. This is balance 3 minus, this is 1,000 plus balance 2. Let's see if that works. So clear, 1 second. Clear amount of interest. Let's start this again. The amount of interest for the year is equal to balance year minus 1,000 plus balance year minus 1. And actually, you could just distribute the minus. And then you will have minus, and then minus 1,000. So let's see if that works. Because we know that these values are correct. Okay. So amount of interest for 1 should be $0. amount of interest for 2 should be $91.80. Amount of interest 3 should be $192.03. Amount of interest 4 should be, now these numbers make a lot more sense. Those other numbers were kind of crazy. $301.46. And then these number, okay, that last number should be amount of interest 5. That should be $420.93. And I'm pretty sure these are correct. It makes a lot of sense that these numbers would be correct. Your input is correct, score 100%. Okay, so we figured out the correct formula to use. Okay, so to figure out the amount of interest for any year is equal to the balance of the year minus the balance of the previous year minus 1,000. I made the mistake of doing 1,000 times the year. That is not correct. It's simply minus 1,000. Minus 1,000. All right, so then table amount of interest year. Year goes from 1 to 5. And this is going to be number form, infinity 2, and let's table form it. So we have $0, $91.80, $192.03, $301.46, and $420.93. And it really does make a lot of sense. And here's the reason why. So I start out with $1,000 plus $0 in interest, okay, plus another $1,000 plus $91.80 in interest, plus another $1,000 plus $192.03 in interest, plus another $1,000 plus $301.46, plus another $1,000 plus $420.93. And what do I have? I have $6,006.22 right over here. Oh, there's a little bit of a rounding issue going on there. The actual amount balance 5, $6,006.21. So there's a little bit of a rounding issue happening right over here, but let's not worry about it. The reason the rounding issue is happening, guys, is because we're rounding everything to 2 pennies. We're rounding everything to 2 pennies or 2 cents. And that's why we're having that rounding issue. Okay, that's why we're having the rounding issue. But right now, don't worry about it. Okay. And we can see that this is correct. Your input is correct, score 100%. Okay. How long is this video getting? Okay, this is almost an hour. It's becoming a very long video. We're going to do one more problem, guys. One more problem, and that's going to be it. Okay, because otherwise this video is going to be extremely long. Okay, we already did this problem. Let's see. We're gonna skip this. So I have to write some answer because otherwise Pearson won't let me move on to the next question. All right, so I'm just gonna enter silly answers because I have to enter something, because if I don't enter something, Pearson will not allow me to answer the next question. All right, let's not do this one. Okay, We did something similar already. Yeah, we did something similar in a previous video. We did something very similar in a previous video. Ugh, for God's sakes. Okay. Well, this one's maybe a little too easy. Let's just skip over this one. Let's skip this one. Okay, let's just skip this. Okay. All right, this problem is interesting, number 18. Let's go over this problem. This is going to be the last problem that we do for this video, okay? A woman borrows $6,000 at 6% compounded monthly, which is to be amortized over 3 years in equal monthly payments. For tax purposes, she needs to know the amount of interest paid during each year of the loan. Find the interest paid during the first year, the second year, and the third year of the loan. Hint, find the unpaid balance after 12 payments and after 24 payments. Okay. So here's what we're going to do. We're going to start over. Clear global. Okay, clear global, clear all of our recent variables. Balance, and I believe this is monthly. Well, first of all, interest. What is our interest? Our interest is 1 plus 6 divided by 1,200. 6% divided by 1,200, okay. Balance month is equal to interest times the previous month minus the payment, but we don't know what that is. And initially it is going to be, let me see, we borrow $6,000. $6,000. Hey, Chad, we'll play later. We'll go outside later. Okay. So this is amortized for 3 years. So 3 times 12 is 36. So what is my equation? My equation is expand balance 36 months is equal to 0. Okay. Okay. And we're going to solve my equation for the payment. The payment is $182.53 approximately. But guys, let's use the entire decimal. Please, let's use the entire decimal. Use all of it. All right, use all of it. Use all those digits. Okay, so payment is equal to payment as it's defined on the previous line. So it's $182.53162470933303, okay? We're not going to round until the very end. Okay, so then we have to figure out the balance. Hold on one second. Okay, we have to figure out the balance, right? And we have to figure out the portion to principal and then the portion to interest. Okay, so our balance is initially, let's see, balance is equal to table, balance month. Month goes from 0 to 36. Okay. Okay, balance month. Month goes from 0 to 36. So this is actually 37 numbers, okay? If we go from 0 to 36, if we go from 0 to 36, right? 0, 0, 1, 2, 3, 4, 5, etc., etc. That's actually 37 integers. Okay, I hope everyone sees that. Okay. So remember, guys, that's actually, 0 to 36 is really 37 integers. Okay. So now we want to do portion to principal. We want to do portion to principal. And in order to do that, we're going to take this number minus this number minus this number minus that number, okay? This number minus that number, etc., etc., etc. So how do you figure that out? Well, that's going to be easy. That's going to be table balance month minus balance month plus 1, and that's going to go from 0 up to, we're going to go from 0 to 35. Now, why am I going from 0 to 35? Because the last month is month number 36. Well, what is 35 plus 1? Okay, 35 plus 1 is equal to 36. So then the last month would have to be 35, right? It would have to be 35. So this would go from, a month would go from 0 to 35. That's the portion to principal. Now, the portion to interest is going to be the payment minus the portion to principal. Okay. This is the portion to interest. It is always the payment minus the principal. So how long is this? Length of portion to interest. Well, it's 36 months. So for the first year, portion to interest, for the first year, okay, I have these numbers. I want to, excuse me, I want to add up these numbers. So that's going to be $308.82. $308.82. For the second year, that's going to be from the 13th month to the 24th month. All right, that's going to be $192.77. And then for the last year, that's going to be from the 25th month up to the 36th month. And that's going to be $69.56. $69.56. And let's see if that's correct. It doesn't seem to like, okay, why is it giving me an error message? Oh, you know what? I have a feeling I know what's going on. It doesn't like, I have a feeling it doesn't like the way I'm rounding here, which is really kind of crazy, but okay. So what we can do here is portion to interest. 1 to 24 minus $308.82. So then this would be 76 cents. And then this would be portion to interest. Well, this would be the total. This would be the actual total. I could just, okay, so minus $192.76 minus $308.82. That would be $69.56. It still seems very plausible to me. Okay, so now it accepts two of my answers, but not the third answer, which is very strange to me. I wonder, why is it, okay, I wonder if it's not accepting this answer. Let me put down a ridiculous answer. Oh, so it did accept this answer, which is $69.56. Let me see if there's a problem with this answer. I'll write down something ridiculous. Oh, I see. So it accepts this answer of $69.59. Okay, why is it giving me an issue with this first one? This is the answer that it does not like. This is the answer that it does not like, which is really strange. Portion to interest. $308.81. Well, it's actually rounded to 82 cents. Very. Oh, I made a mistake with this one here. Sorry. This should be $192.76. So, okay. So it seems to like these two answers. It seems to like these answers, and for some reason it doesn't like this answer, which is very weird because if this answer is wrong, these two answers should be wrong too, which is very, very strange. Let me try 1 penny. Let me try 3 cents. Yeah, that's very strange that it's giving me a hard time over just that one. It doesn't seem to like this answer, which is very, very, very strange. That is very, very, very strange that it does not accept it accepts these two answers. It accepts these two answers, but for some reason it does not accept this answer, which is really weird because these two answers are actually based on that answer, which is very strange. One second. Okay, I'm curious to see what their answer is. I'm going to say this is question number 18. This is question number 18. Okay, let's submit this. Okay, you have not completed your assignment. Okay, whatever, that's fine. Submit test. Let's go to question number 18. Very interesting. So you answered $308.82. The interest paid during the first years, according to Pearson, is $308.76, which I don't quite agree with. I don't quite agree with that. I believe the answer should really be $308.82. The reason I don't agree with it, if this answer was actually, if this answer was wrong, if my answer was wrong, these answers would not have been correct, because these answers are actually based upon this value right over here. So it's saying to me, you answered $308.82. Pearson is looking for the answer $308.76. I'm going to argue that my answer is actually correct, because if my answer was not correct, then this answer would have been wrong and this answer would have been wrong, but Pearson actually accepted them. Pearson actually accepted these answers, which means that my answer here must have been correct. So this is where I'm going to disagree with Pearson. I think Pearson's answer is actually a little bit off. I believe that my answers are more accurate, more correct. Okay, guys, that's going to be it for now. All right, I did as much as I can do. I didn't do all the problems, but I did as many as I could for right now, and hopefully this video will provide you with some assistance. Okay, take care. Have a good day.